All right, we're live. So let me drag the chat over this way so I can watch anyone who wants to answer as we go. Can answer in there. And let's hop straight into this. So let's start with a more straightforward confidence interval question. So this question says that a poll of the population of Nowheresville, Kentucky shows that 53% of the participants are voting for the mayor's reelection, and the poll has a margin of error of 4%. So in this question, we are given the margin of error. So, all right. First question, which I'm going to throw to you in the chat. Which of these numbers is the point estimate? And how would we write it in Excel? P-hat is 0.53. Very good. So you can answer in percent, but it's better to use decimal. So yeah, absolutely right. We'll say P-hat is 0.53. And the error, which I'm going to call E, was that 4%. So with that, how do I get the lower end of the confidence interval, and what formula should I use? See, p-hat minus E. Someone else says p-hat minus E over 2. So we have some disagreement here. What do we think about this, folks? 0.53 minus 0.04. That's the right way to do it. 0.53 minus 0.04 would give you the lower. So you do not have to divide by 2 here. You can just use p-hat minus E. And just for clarity, I'm going to pop this into the presentation. I'll be sharing this after the workshop is over. And I will label that this is p-hat here, and this is E here. What if I wanted to get the upper instead? What would I change? I would add instead. Very good. Absolutely correct. Yeah. So instead, I would go equals p-hat plus error, and that would give me the upper. Okay, so I do want to clarify something. When you are, I saw someone say error divided by 2. There is a variation on that problem that involves dividing by 2, but it's not this one. So if I had said, what if I had said the interval is, let's say, 0.4 to 0.6? If they phrase it this way, the lower is always your first number and the upper is always the second number. Okay? So if you want to find the p-hat, if they go ahead and just give you the interval straight up, you take the average of the upper and lower. And the formula for that in Excel is just equals average of the upper and lower. But I think where the dividing by 2 came into play here is if they asked you for the error here and they gave you the interval, you would take 0.6, subtract 0.4, and then divide that by 2. But that's completely different from what we did earlier. All right, so that's probably the only place where you're going to have to divide by 2. So I want to make sure that you know that there is a place for it, but it just wasn't that example. All right. So let's try actually putting together a confidence interval if they don't give you error. So mission number 1 for these sorts of questions is to gather up the ingredients. P-hat, Q-hat, just typed there, in, and confidence. All right, so let's have a look at this question. Which of these numbers would be our p hat? I'll give you a moment to read it. Also, just in case anyone asks, I don't believe in invisible mayonnaise, but somebody does, I'm sure. 0.12. Absolutely right. Now, how do I get q hat if I know p hat? One minus, very good. Absolutely right. Will equals 1 minus that answer, and I will pop that into the presentation like before. And then what is my in here? 422. Very good. And the confidence, of course, is 95%, 0.95. All right. Number 2, I'm going to calculate alpha and then calculate Z critical based on alpha. Okay, so confidence was 0.95. Some of you might already know what I'm about to ask you. If I know the confidence is 0.95, now someone's already got it. You're absolutely right. You're going to say 1 minus that to get alpha. So we're going to go equals 1 minus the 0.95. That's going to give us alpha. All right. And let me just put the notes on here that this was 1 minus p hat and this was 1 minus confidence. Well, now that I got that, I do understand that different instructors may give different formulas for Z critical. And so there may be more than one correct answer here, but if I know alpha, what did they give you to get Z critical with? Let's see, 0.025, not quite. How would, I see what you're trying to do. That's not going to be enough to get Z critical. There's a norm inverse of 1 minus alpha over 2, 0, 1. Let's see, yeah, I do believe that'll work, but you got to be real careful how you type that. Yeah, that will work. So now you don't want to use 1 minus. So let me just punch all this in. So you can say norm inverse 1 minus alpha divided by 2 comma 0 comma 1. That will work. I have another one that I want to show you. I think it's a little easier to remember. So this is actually fine. But another way you can do this is to say equals negative norm S inverse of alpha over 2. Little bit easier to type and a little less likely that you'll end up making a typo. So you can say equals minus. Again, as I've said, it's there's more than one correct answer to get Z critical, so it just depends on who your instructor is. I bet you if you asked a third person, they might have a different formula from me. I'm partial to the second one myself. All right. Now that we know how our Z critical and our alpha, step number 3 is going to be now use the error formula. So what is the formula for error now that we have Z critical? Who remembers this one? I will give you a hint. It starts with Z. But then what do I do? So I've got some ideas. Z times square root of PQ over N. Absolutely right. I can't award you any points on your exam for getting that right, but yes, you got it. Give the rest of you a moment to finish typing because I don't want to cut you off. So I'll go ahead and punch this in. I'll make sure that everyone's on the same page here, but I'm going to go ahead and type this. Z critical times square root of p hat multiply q hat divided by n. Close the parentheses. Make sure you open right after the square root. Make sure you close after you're done. And just for anyone who's struggling with this, I will make the notes. There's z, there's p hat, q hat, and n. That gives you the error. Once you got the error, we can just put together the confidence interval like we did last time. We can say p hat subtract error for the lower, and p hat add error for the upper. So you can see these are fairly similar to what we did previously. As long as we know how to get the error, we're A-okay. Make sure I didn't miss anything. Yeah. All right. So that is how we get a confidence interval for proportions. Now let's do another example, but this time let's do one for means. All right, so here we've got the average worker at RTP has a commute time of 55 minutes, standard deviation of 21 minutes, according to a poll of 250 people. Find the 99% confidence interval for the true average commute time. So our first mission, number 1, is to gather up X bar, standard deviation, N, and confidence. So first off, let's start on line 2. It says the commute time is 55 minutes. What symbol goes with that 55 minutes, and where do I put it in my Excel table? Yep, looks like everyone knows. It goes next to X bar. And then the 21, where does that go? Standard deviation, yep, good. And then the 99% is the confidence interval. We'll say 0.99, and the N is 250. So, yeah, everyone knows what goes where. We've already gone through how to get alpha, so that's our second step. We're going to calculate alpha, then calculate T critical based on alpha. Just move this so I have enough room. So alpha, we've gone through how to get that already. It's 1 minus the confidence. Now that we know alpha, what formula do you use to get T critical? And I believe there's, again, multiple ways that you can get this, but so T inverse 2 tail alpha comma degrees of freedom. That's right. Seems like everyone's got a good handle on that. So we'll go over here. Equals T inverse 2T with the alpha, comma, and then for your degrees of freedom, what I recommend is saying the end located there in B7 minus 1. So notice that I'm not making a separate field for degrees of freedom. I'm just entering N minus 1 directly. So press enter and pop that in. All right. So now that we know that, let me go ahead and make the notes above here to show that this is my alpha and this is my N minus 1. Now that I have that, step 3 is going to be to find error based on T critical. So what formula do I use to get error? Someone's already one step ahead of me. So T, I notice you're saying alpha over 2, but that just That's just you don't have to say alpha over 2. It's enough to just say t as far as I'm concerned, but some instructors might be more critical of that than I am. We're going to say equals t multiply standard deviation divide square root of n. And again, we'll make the notes here. This was the t, this was s, and that was square root of n. Now that I know the error, how do I find the lower and how do I find the upper? X minus error. Very good. Let's say the X bar minus error will give you the lower. X bar plus the error for the upper here. So we'll just head over to Excel and pop that in. And there we go. And you can reduce the number of decimal places to whatever you feel is appropriate. All right. Now here's the third variation on confidence intervals. So we're going to run this process twice. We're going to have a part A and a part B. So this question says that we want a 95% confidence interval for the proportion of people who own a security system with a 3% margin of error. And we're asked to find the minimum sample size. Check the chat here, make sure I didn't miss anything. Okay, well, someone else got it too. Excellent. So now, part A, to find the minimum sample size if there's no initial estimate. So I want to key in here on the words no initial estimate. So if there's no initial estimate, what do I put for p hat? Is 0.5. Excellent. So for part A, we're going to say 0.5 if there is no initial estimate. And then put that in for p hat. And our q hat we know is just 1 minus that. How would I write my margin of error? .03. Very good. And my confidence is 95%. Now we just went through how to get alpha because that's 1 minus the confidence. And we went through how to get z critical because you can use norm equals minus norm S inverse. And then alpha divided by 2. All right, so now that we have all that gathered up, how am I going to find my n? What's the formula for that? Yep, very good. So P times Q times Z over E squared. You can also write it like this. You can say Z raised second divided by E raised second multiply P multiply Q. But the way that you typed in will work. So we're going to go P hat squared, Q hat squared. I'm sorry, I wrote this in the wrong order. So P hat and Q hat go over here. And then I've got Z over E right there. So Z squared over E squared times P hat times Q hat. So that will do the job. And now that I have this answer, there's one more thing I have to do to it. Does anyone remember? Always round up. Very nice. So you can't pull 0.072 of a person, so you may as just pull one more person. So we round up and we say 1068. So now I want to show you how this changes if you do have an initial estimate. All this is going to do is change the p-hat to 0.35. So then we can let Excel autocomplete everything else. Error doesn't change. Confidence doesn't change, which means alpha also does not change. And because alpha does not change, Z critical does not change. And now all I need to do is run the formula again. And do you see that having an initial estimate lowers my required sample size? We need fewer people than before. Because rather than 1068, now we only need 972. And what I find is usually if your p-hat is really low or really high, that can lower your sample size even further. All right, so it seems like everyone's got a pretty good handle on how to do this stuff. So with that in mind, does anyone want to go back over anything about confidence intervals? Does it make sense how we constructed the intervals for both means and proportions? Did anyone run into some confidence interval questions they want to throw at me before we go on to hypothesis tests? All right. Oh, got something in the chat here. Where did 0.5 for the p-hat come from? So the rule is for part A, we had no initial estimate. So if we don't have an initial estimate, we use a default value of 0.5. But if they do give us an initial estimate, we just use the initial estimate they give us and put that in the p-hat box. All right, no worries. So let's move on to hypothesis tests. And so let's first do a hypothesis test. Oh, I got someone else in the chat here. What's Q-hat again? Okay, so Q-hat is something we covered before you came in, I think. So I'll just say it one more time here. So Q-hat is always 1 minus P-hat. So anytime that comes up, that's what they mean. So if you know P-hat, you always get Q-hat. Yeah, no worries. All right. So that being said, let's have a look at a hypothesis test question where we're going to start setting up the hypothesis test, and we're not going to do any math just yet. All right. So if we read this, it says in a group of 1,000 fourth graders, 600 of them believe in the tooth fairy. We're going to test the claim that a majority of fourth graders believe in the tooth fairy at a 0.10 significance level. So step number one, when you are setting up a hypothesis test, is going to be to write out the claim in symbolic language. Okay. So our claim is that a majority of fourth graders believe in the tooth fairy. Someone's already got a chat for me. I think someone might already know the answer. Yep, you already got it. So you are close. Okay. I want to amend this ever so slightly. So what they're saying here is that majority means greater than half. Okay. So greater than is this symbol. And half stands for 0.5. I noticed that you put that is the alternate hypothesis. You're right about that as well. But there's one more thing I wanted to think about here. So I want us to answer, is this a mean or is this a proportion? So when we say the word majority, what does that apply to? Is that about means or is that about proportions? Proportions, yes. So I want you to remember, when you're doing the notation properly, proportion, whenever you're answering anything about proportion, you're using a lowercase p in the claim. So you must write lowercase p greater than 0.5. If it was mean, you would use the Greek letter mu. We are going to write that this is the claim. All right, that being said, yep, because it's a percentage, yep, anytime we're talking percentage. Now, that being said here, what is the opposite of greater than? That's step 2. Less than or equal. Very good. Very good. Just for those of you who are having trouble seeing this, just remember that greater than is the opposite of less than or equal. This was meant to be greater than. I wrote this backwards. Let me fix that. And then less than is the opposite of greater or equal. And then not equal is the opposite of equal. Also, be careful about your claim. If you see any of these symbols that are on the left in your claim, this means your claim is the alternate. That's abbreviated HA. If you see any of these on the right in your claim, that means your claim is null, or HO. So as we've just said, we had greater than, and so the opposite of that claim is less or equal. We're still going to say P, we're still going to say 0.5, and we're going to write that's null. And that's correct. You can say H1. That's the same thing. All right. So here is where we're going to dive a little deeper into this. Step number 4, we're going to write the possible outcomes to the test. So let me get my keyboard out here. And the first outcome is we could have strong evidence. Now, if we have strong evidence, that means we can cross out the null hypothesis. So just imagine how that would look for a second. If I did have strong evidence, I would just draw a line through the null hypothesis. And can you see that this would leave behind the claim if we did cross out the null? So crossing out the null leaves the claim behind. And that means we can support the claim. And we can support the claim because the evidence is strong. But what if we had weak evidence? That means we cannot cross out the null. And the words we use to describe not being able to cross out the null, we say this is fail to reject. What that means is we don't have strong enough evidence to be able to cross the null out. That means we have to keep the null. And that also means we are not able to support the claim. And the reason we can't support that claim is because we don't have enough evidence. Okay, so those are the two things that could happen. Might have strong evidence, might have weak evidence. So our question we're going to have to answer through our calculations is the evidence strong or is the evidence weak? That being said, let's head over here and start gathering up our ingredients. So we are going to need to look for the X, the N, the P hat, the P, and the Q. All right, so I'll pose this question to the chat. What is our X and what is our N? Any ideas? 600. Oh, we have a little bit of difference here. X is 600, N is 1000. Somebody skipped ahead a little bit and said 0.6, but you're a little early. The X was 600, the N is 1000, and the person who said 0.6, I think I know what you were trying to do because that's actually P hat. So P hat's actually X divided by N. That's where the 0.6 goes. And just to remind ourselves, let me go ahead and grab the null and alternate from the previous step and pop them onto this page. Okay, so now we got the X, N, and P hat. How do I get P and how do I get Q? What's my P going to be? $25, very good. That's right. So remember that your P comes straight from the claim. So whatever your claim says, that's your P, 0.5. And then Q is just going to be 1 minus the P, just like before. So now we got everything we need. So who can tell me what the formula is to find Z? P hat minus P divided by square root of P times Q divided by N. Very good. I think you knew I was headed there. You typed that in real quick. Just banged it out there. So we go P hat, subtract P, divided by square root of P multiplied by Q divided by N. And this is why I typed all of these in different boxes. Just because I knew we were going to see those again. And I'm going to label all this to make sure that we know where everything goes here. So we're going to say P hat minus P, and then here, make sure you put the P in the Q. P hat only goes in the first slot, but nowhere else. So P hat minus P in its first parentheses, and then down here put regular P, not P hat, times Q divided by N. Gives you your Z score. Now that we have Z, we can get the big P value, that's step 3. So we're going to get, I'm going to show you how to get the left, the right, and the two-tail. So when you are doing proportions, who can tell me how we're going to get big P for the left? Any ideas? If you're stuck, I'll get you through this. It's okay. Norm dist Z011. Yes, that will work. That is one way of doing it. It's not my favorite way to do it, but it will get you to the right answer. All right, so I'm going to make a note here. This is P on the left. But what you can also do is you can say norm sdist, your z-score, comma, true. So if you've seen that, it'll work too. Let's see, tdist right tail. Now you don't want to use tdist here. That's not the one that's going to work because what we're doing here is a normal distribution. So tdist would actually lead you the wrong way. What you want to do instead is once you get P left, you can get P right in one step using this formula. You might face palm when you see it. You can just say that equals 1 minus whatever P left is. So you can say 1 minus your P left. And that's good enough. Yeah, it's okay. You don't lose any points. It's fine. So also notice that if you see E notation, I know like some people when they see this, they get a little weirded out. If you see E and then -10, that just means you have a really, really small decimal. It's a decimal so small, it's almost 0, but not quite. So now, if I want to get the 2 tail, what do I do? This one's not obvious. If you haven't seen it before, it's going to be hard to guess. Times 2, well, that's part of it, yeah. 2 times what, though? Which one am I multiplying by 2? I'll tell you a way that might help you, okay? So to get the 2 tail, what you can say is say 2 equals 2 multiplied, and then you want to take whichever one of the 2 above answers is lower. So you're going to say MIN to tell Excel to look for something that's lower, open parentheses, and then select your 2 tails. So 2 times the lower of the 2 answers above. And so there's your Excel formula. Now notice this scientific notation is going to mess you up a little bit. So if you get an answer in scientific notation, go ahead and change back to a standard decimal. So if you see that E -10 business, and the way you change to a standard decimal is to go to home, and then do you see in this number section where it says general? You don't want to have general, you want to say number. Notice that it gives us a 0 in this box. It's not really 0. I'm going to warn you, it may appear as 0, but it's just really small. So to see that, if you increase the number of decimal places, notice it still says 0, but if I keep going long enough, the numbers start to appear here. But it took a lot of zeros for us to get there, and this number is really teeny tiny. I'm going to switch this back to a reasonable number of decimal places, but I did want to show you that so you're not confused about what that means. So now that we've gone through the formulas about how to get your big P, can you remind me, is this left tail, right tail, or 2 tail? Which one of those values do we need? It's right tail. Very good. So I just want to warn you that to figure out the tail, look to the alternate. So if you see less than, that means left. If you see greater than, that means right. And if you see not equal, that is two tail. Now, as you said, it is indeed right tail, and the reason for that is because the alternate said greater. Greater means right tail. All right, with that in mind, let's go to the next part. Okay, so now let's rewrite our claim. So the null was that P was less than or equal to 0.5. The alternate was that P is greater than 0.5. That was our claim. And then our big P value was 0.000 with a whole bunch of zeros after it. So let's decide if our evidence is strong or weak. Our big P was 0, or at least close to it. Our alpha was 0.10. So based on this, we can see our P is less than alpha. Someone I think already knows where I'm headed with this. You're right, you reject the null, but also, is the evidence strong or is the evidence weak? Oh, it's the other way. Oh, ho, ho. Hang on a second. Oh, the results are coming in, folks. Yeah, you're right. It's going to be strong evidence. So the lower your big P is, the stronger evidence you have. So big P is the probability that you got the results you did by accident. If this is low, the evidence is strong. And if the evidence is strong, you can reject the null and cross it out. So that means we're going to come up here and cross the null out. So check the chat. And there is sufficient evidence. Absolutely right. That's where I was headed next. But does that mean we support the claim or does that mean we reject the claim? Absolutely, we support the claim. So if we are going to write the conclusion, we would say we have sufficient evidence. So you can think of this as a series of multiple choice questions. You can say we have sufficient or strong evidence at the significance level, which was 0.10, and therefore we rejected the null hypothesis, which means we supported the claim. And then if you're going to answer this on a test, you want to restate what the claim said. And the claim said a majority of fourth graders believe in the tooth fairy, I think I said. All right. So I want to actually, before we go any further, this fourth line here where I've got 4 different options. I want to do a little bit of clarification before we go any further. So we're going to say if the claim was null, that means we reject if we have strong evidence. And then we fail to reject if we have weak evidence. But if the claim was alternate, we support if we have strong evidence. And then we fail to support if we have weak evidence. So it can help to go back and look and just remember, was the claim null or was the claim alternate? Since our claim was alternate, we would say support if we have strong evidence, which we did, or fail to support if we had weak evidence. I would definitely put this on a flashcard in front of you because it's easy to mess the words up if you're not used to it. All right. All that being said, does anyone want to go back over why we selected what we did in this conclusion? And again, if you want to copy this down, I'll send everybody a copy of this once we're finished. So you don't have to write everything down right at this moment if you don't want to. All right. That being said, let us go on to another form of hypothesis test. So this time we're going to do a hypothesis test with something in the chat. Oh yeah, this recording is all going to appear in the channel. I will warn you, if you're logged in as a guest or if you're logged in under a different account, you won't be able to access it until you log back in with your Wake Tech account. So I noticed some people in the chat were listed as guests and some people are listed as unverified. You'll be blocked from reaching that recording until after you log back in with a Wake Tech ID. This is for those of you who are members of multiple organizations that may use Teams. Make sure you are logged in under your Wake Tech ID to have access, because only members of the Wake Tech organization can get to it. I'll also upload this onto YouTube eventually. I don't know if it's going to be before anyone's exam, but we'll get it up there at some point. All right, so we now have a hypothesis where we're going to deal with means, and 30 Math 152 students were asked for their commute time to school. And then we're going to test the claim that the mean commute time is no more than half an hour at the 0.05 significance level. Okay. Our claim, let's just go back over the wording. Claim says the mean no more than half an hour. Okay. And the answers are given on the next slide in minutes. So how would I write that claim? What letter would I use? What symbol would I use? And then what number am I looking for? So we got to think about the letter, think about the symbol, think about the number. Okay, I'm seeing less than or equal to 30. I'm seeing H null here. Some people are saying less than 30. So we have something of a scatter shot here. Anyone else have any other ideas? Oh, I got you. I see what you mean. Yes, you're right in saying it's less than or equal to 30, right? So you're right about the symbol. The symbol is going to be less than or equal. You're right about the 30 because that's the same as half an hour. The letter we're going to use is going to be mu anytime we do means. And then that is going to be the null. So we will say null, mu less than or equal to 30, and that is the claim. So how would I write the alternate? Greater than 30, right? So we'll say mu greater than 30. And let's think about the possible outcomes. So here's what I want to ask you next. What if we had strong evidence? What would we be doing to the claim if our evidence is strong? Exactly right. Oh, we have mixed messages here. So I want to make sure we understand. Yeah, it's okay. I want to make sure we understand why that is, though. Okay. So if we have strong evidence, that means we can cross out the null. All right. So if we cross out the null, just use your imagination. Imagine if the null was crossed out. Can you see that in crossing the null out, I've also crossed the claim out? So this means we have rejected the claim. And the reason we can reject the claim is because we have enough evidence to do that. Now, if we don't have the strong evidence, we got to keep the null in that case. I'll write this down. If we have weak evidence, we can't cross out the null. So what would that mean for the claim? What would we be doing? I'm going to copy the table over that we had last time, okay? Just to make sure we understand this. I'm going to pop this over here. Oh, get more room here. So if the claim was null, we reject if we have strong evidence and fail to reject if we have weak evidence. So because we can't cross out the null, we would fail to reject the claim because we don't have enough evidence to do that. So think about like a court program. Like, I don't know how many of you watch those old courtroom dramas, but like Law and Order or something, where like the prosecutor comes in and tries to present his case, but like if he doesn't have enough evidence, then they can't find the suspect guilty. It's kind of like that here. If you don't have enough evidence, you can't cross out the null. That means we got to let the null walk free. That doesn't mean the null's innocent, but it does mean we can't find him guilty. All right. So again, definitely put this on a flashcard right here. So let's find out what our math is like. So our first mission here is to gather up the x bar, the mu, the s, and the n. And let me go grab the hypothesis pair from back here before we go any further. Drag that over. All right, so if I have a list of data, how do I find x bar? Average, very good. So I'm going to go equals average of the list. What do I use for mu? 30, exactly. The mu is going to be the claim number. And for X bar, we used equals average of the list. Now the S. What formula do I use to find the standard deviation? What you think? STDEV.S. Very good. So STDEV.S of the list. There we are. And then for N, let me show you a little trick here. You can say equals count of the list. All right, make sure I didn't miss anything. Yep, very good, everybody. So now that we have all of that stuff, how do I find T, the test statistic? What's the formula for that? Oh, that's my alarm. All right, any ideas for T at all? X bar divide by mean, divide by S, divide square root N. You're close. I think there's a typo in that. There we go. That's the one. But remember one more thing, that when you type this, you want to say equals parentheses X bar subtract mean. So it's X bar subtract mu, then divide, then get a new parentheses, then go S over square root of N, then double close. So I'm going to make sure that we understand what goes where here. So notice that the first part of this formula gets its own parentheses. So you can think of the first part of this formula as being X bar minus mu, and it's going to have its own parentheses. Then slash, then a new parentheses. That's going to be the second part. And then you'll say S over square root of N. Yeah, I think you knew there were more parentheses in there. It's just hard to type it in all at once. All right, well, now that we have the test statistic, let's talk about how to get big P. So now that we've got T, what is the formula for P left? I would do P left first, though, here. I know, like, they may have some formulas for P right, but sometimes Excel bugs out, especially with certain versions of them. If I wanted to go for P, if I want to go for P left, what would I do? Anyone remember the formula? T dis T something, so yeah, close enough. I'll take it. Yeah, it's good enough for now. Yeah, it's right. It's T dist. You know you got to put in the T. And then we're going to go N minus 1 in the next part. And then true. There you go. So just for the notes, we'll have t in the first part, n minus 1 in the second part. Then for the right, now you can do t-dist right tail. That would be okay. My preferred way of doing it would just be 1 minus whatever the left is. So if you need the right tail, what I would recommend that you do is go ahead and get the left, and then just take 1 minus that to get the right. And then for the two tail, you can still just reuse the same formula, 2 times min of both of those. So the reason why I'm presenting it this way is that it's fewer things you have to remember. Because finding the right tail from the left tail is always the same thing, and then finding the two tail, if you know the others, is still always the same thing. So really the only difference between this is that we're using t-dist rather than norm s-dist. And I'll just put the formulas right there for you. So now, if we look to the alternate, is this left tail, right tail, or two tail? It's right tail. Very good. So the right tail right there is the answer. Boom. So now let me copy over the information that we know onto the next slide. Move this where it belongs. And we will write that big P was 0.5. So let's compare big P against alpha. Big P was 0.5, alpha was 0.05. So do we have strong evidence or do we have weak evidence based on this? Yep, we have weak evidence, exactly. So big P is greater than alpha. That means that we have weak evidence. Can we reject the null or do we fail to reject the null? That's right. That's right. Weak evidence. Again, I want to bring you back to this table. The claim was null. And because we have weak evidence, we fail to reject. So write that down. We've not only have we failed to reject the null, but we have also failed to reject the claim. Okay, so when we write this again, we're going to say that we have weak or insufficient evidence at the 0.05 significance level. We have failed to reject the null hypothesis, and we also means we can't reject the claim. Exactly right. We don't have sufficient evidence to reject the claim, right? And then after that, we restate the claim, and the claim was that the mean commute time is no more than half an hour. Okay, so again, You may want to put this on a note card to just remind yourself that when they ask you for an interpretation, this is what you'd put on there. All right, we may have time for one more. So we will move on here and, well, if anyone wants to ask me anything about this, I'll give you a moment to type your questions. But if not, we'll move on to the last problem in the set. Make sure I didn't miss anything up here. Okay, there we go. I think we're good. All right, let's move on to the final part of the set here. So now we're going to do a hypothesis test with differences. So a group of 10 Math 152 students had their exam taking times measured for exam 1 and exam 2. Wait, let me check here. Yes, insufficient means the same thing as weak. Right. So test the claim that the exams took the same amount of time. Okay, so our claim says that it's the same amount of time. So let's see who wants to take a shot at this one. How would I write my claim here? It's a tough one, so you may not have seen this before. I'll give you a moment to think it over. All right, looks like we're a little stuck here, so I'll help you out with this one. So the same amount of time. Oh, someone want to give it a try? Yeah, someone's got it. Yep, that's right. Mean is equal to 0. I'll tell you why. So the same amount is another way of saying equals. It also means that we have a difference of 0. So the way we write that for a difference hypothesis is we say mu equals 0. As you say, that is the null, and that is the claim. So how would I write the alternate given that? Not equal to. Very good. We say mu not equal to 0 is the alternate. And let's think about the possible outcomes. Again, I'm going to copy the table from here so we can think about the possible outcomes. Let me just remove the coloring from this. So we've just said our claim is null. So there's two things that could happen. If we have strong evidence, we reject the claim. And if we have weak evidence, we would fail to reject the claim. And if the claim was alternate, we would word it differently, but that's fine. So let's move on to the next part because I'm a little low on time. So for this problem, I've given you a list of exam 1 times and a list of exam 2 times. And my first mission here is to complete the difference column. What operation would I do to complete the difference column? Subtract, very good. So I'm going to go equals exam 2 minus exam 1 and copy all that business down. And now we've got my difference column. So with that said, how do I get D bar? Take the average, very good. So equals average of all this business. And then what's my mu going to be? Yep, the average of the differences, absolutely right. Mu is going to be 0 because that came from my claim. And then what about SD? Okay, yep, we know mu is 0. What do I say for SD? STEV.S, very good. And I'm going to do this on the difference column. And then my N. Here's a tricky one. What do I say for N here? Very good. So we're going to make sure that when we say N, we're going to say 10. This is the number of difference results, not the total data set. Okay, so once we find the differences, we're only going to look at these. Now the test statistic is just the same as before. We'll say equals, this time d bar minus mu over another parentheses, s over square root of n, just like last time. There we are. And then once we've got all that, we can get the p left, p right, and p two-tail. So again, remind me what formula I used to get p left. Yeah, which dist do I use? Which dist should I be using? Is this going to be normal or is this going to be t? T dist, very good. T dist, yep, degrees of freedom, there you go. So go t, dist, put the t value in, comma, n minus 1, comma, true. That's my formula for the left. And then for the right, I'm just going to do 1 minus the left. And then for two-tail, I'm going to take 2 times whichever of those is lower. So 2 times min of those two, like before. Well, now that I've got this, which of those numbers should I use? Is this left tail, right tail, or two-tail based on my hypothesis pair? Am I left tail or right tail or two-tail? It is two-tail. Very good. We will paint that green. So now we go on to the next page. So let me copy my hypothesis pair one last time. All right, so we have said the big P is 0.30, alpha is 0.01. Do we have strong evidence or do we have weak evidence? It's weak evidence. Very good, because big P is greater than alpha. So if I have weak evidence, does that mean I can reject my null? I fail to reject. Someone already knows where I'm going with this. We're going to fail to reject the null. Write that down as well. Here's the big test. What does that mean for the claim? Not insufficient evidence to reject, but here's the tricky part. We can't support the claim either. Let's go back to that table that I popped on to the hypothesis tests here. We'll refer back to this. Make more room here. It's the hardest part of insert the copied cells. There we go. Oh, I think I messed something. Nah, I messed it up. Let me try again. Shift cells down. There we go. Better. Figure that. Okay. So we said that we have the claim was null, and we have weak evidence. So I'm going to paint that as well. So this means that we are failing to reject the null, but also failing to reject the claim. Okay. We only say support the claim if the claim was alternate. And so since the claim was not alternate, we actually can't say that. We only say support the claim if the claim is alternate. Since it was null, all we can say is that we also fail to reject the claim. So just because we fail to reject it, this doesn't mean we can support it. So those are not the same thing at all. We can't actually say the claim's valid. No. All we've done is say that we can't cross it out. Okay? So we can't say it's wrong, but that doesn't mean we say it's right either. It just means we don't have enough evidence to cross it out. So I want to say that just because we've failed to reject it is not the same thing as validating it. I'm going to type that in because that's a big deal. We're not validating the claim. We're saying we don't have the evidence to cross it out. So this is like, again, it's like a courtroom. If the prosecutor comes in without enough evidence, we got to let the suspect walk free, even if the suspect's guilty. The reason why is because the prosecutor has to prove it. So even if it's true, if we can't prove it, we have to say so. So we have to let the null walk free today because our evidence wasn't strong enough. So the only one that can be valid is when the alternative. Yeah, there you go. Now you got it. You got it. If the claim is the alternate hypothesis and we're rejecting the null, then we support the claim. But that's the only time we can support it. So in conclusion, we have weak evidence at the 0.01 significance level. We can't reject the null hypothesis, and that means we also cannot reject the claim. And the claim was there is no difference in time. All right, that's all I have for today. So let me save a copy here. And this is exam 3 workshop, math 152. And this was the 15th. And pop that in the chat now. There we go. And let me make sure everyone can get to it. So we're going to say anyone in the organization can get there. Apply that. Yeah, this chart's fine. So just based on what the claim is, you can, yeah. That chart's okay. You can use mine too. They both say the same thing. All right. There is your presentation. I'm going to stop the recording, and when I stop it, it's going to start transcribing.